Hello everybody, just bear with me for 1 second while I scroll forward to the slide I need to get to here. Okay, sorry about that. So, excuse me. My apologies for not being there. There is one thing that I can say for certain, which is that, I don't sound great and I'm past the worst of it, so, whoops, oh man, I'm so sorry. Turn that off. And I'm past the worst of it, so you do not want the flu. I am gonna keep you all safe and stay far away. I'm recording this quickly to help you out because we're on the biology chapter, which is a lot of very important material, but material that it helps people to go through a little bit, and I didn't want to leave people without guidance, and what I ultimately decided to do was go ahead and record some of the lecture comments we would have gone over today. And I do have good news. You don't have to listen to this whole thing of me talking in this voice, because coincidentally what happened was in a prior semester I had a business conference or an appointment or something that was happening on the day we were going over some of the biology units, and I recorded a video. So it doesn't map up perfectly to where we left off. So what I'm going to do is record for you starting where we actually left off on Thursday, talking about the end of this chapter 1 material, and then I'm going to record a little bit of the chapter 2 material, and then at some point I'm going to turn you over to a video of me suddenly sounding well, where it'll be more pleasant to listen to than I recorded last semester, but it's still the same material. So if you watch them in order, it'll map up, it'll line up, it'll make sense, it'll be great, and hopefully you guys won't feel unprepared for your exam. Let's finish up here. We were talking about, on Thursday, we left about to do this hot seat poll, and the internet wasn't working very well in the classroom. We will kind of forego that, given that I'm not there today. But the answer to this question is this is a quasi-experimental design. And if you could do that easily, you're probably going to be good for a quiz or a test. This is a quasi-experimental design because it feels like an experiment in that you have a control group that you're comparing to an experimental group. You have people you're putting through that were put through the experience of being married that you're directly comparing to a group of people that were not put through the experience of being married. That feels a lot like an experiment. And you've got your average happiness scores for both that you're comparing, and you want to see is the average happiness score higher for the group that was put through the experimental experience of getting married. All that feels like an experiment, but remember what you have to ask yourself is, how did they get assigned to the control group versus the experimental group? Did someone flip a coin? Did a random number generator determine it? And obviously no, because there's going to be some practical and ethical issues with that in this example that we're using. You can't flip a coin, and if it lands on heads, say you're getting married, and if it lands on tails, say you're not. I don't know many people that would sign up for a study that involved that kind of procedure. And that's what makes this a quasi-experiment, because it looks, feels, smells like an experiment in all ways, with the exception of how the participants were placed, what determined whether or not they were placed in the experimental group or the control group. In this case, not random assignment, but they basically self-selected whether or not they themselves had otherwise decided to get married or not, determined whether they were in the experimental or control group for this one. And very often, it is practical or ethical concerns that make something a quasi-experiment instead of a true experiment, because random assignment is not possible. Okay, just to finish up these few remaining Chapter 1 slides for you here, we've gone over all the major designs. There's just a few additional measurement issues in social psych research, or sorry, that should say just psychological research, that are important to talk about here. And the ones at the end here I like to make sure people are comfortable with are the notions of reliability and validity. These are things that you will hear people discuss so much. It's important just to take a couple minutes to highlight these. Oftentimes when someone publishes a research article, what you will hear is one of the biggest criticisms of your measure is that it either maybe wasn't reliable or it didn't seem valid. And you need to know, what do we mean by those two different words? If these are basically just two different things that get at, is your measure a good measure? Remember we talked about operational definitions and how you're actually going to measure these abstract concepts you're interested in. Well, because it's hard to determine how you're going to do that, there isn't one agreed upon necessarily correct way. What people critique is how good was the measure we came up with, and they do that through the lens of was it reliable and was it valid. Reliability gets at how consistent are responses on the scale, and validity gets at how accurate was it. So imagine I was not sitting in my home with the flu and instead was up in front of you talking, which is where I'd much rather be, and there was a scale there at the front of the classroom, and I stood on it, and it displayed this big number, 8. Then I got off, then I got back on, and it said once again 8. Then I got off, then I got back on, and it said once again 8. If I was getting the same response every time, that would be a really reliable measure. It's giving me 8 every time. It's consistent. But what we would say is it's maybe not a valid measure, because while it's reliably measuring something, it's not reliably measuring what I want it to measure, which was my weight. At least not in pounds, because I don't weigh 8 pounds. So who knows what it's actually measuring? We would have to do more investigating to kind of find that out. Validity gets at how accurately does it capture what you want to capture, and reliability is how consistently does it produce that. So when you are having participants self-report on something, like just tell us how happy you are. There are going to be some problems with that. Will the responses be reliable? Will they be valid? A lot of people might say, well, it's not a valid measure of happiness. It's not going to be accurate because people are going to misrepresent themselves as being happier than they actually are. So a self-report of happiness, you might say, isn't a valid measure of true happiness because it's accurately measuring how happy people are willing to say they are, not how happy they actually are, which is what we want to measure. So that would be a validity criticism of a self-report measure. So when you're talking about self-report measures, there's a lot of different issues that can come into play. You could try a behavioral measure where you could observe what people do instead, and some of those might reduce some of the validity concerns. But these are the things you think about when you're criticizing the operational definition that has been selected. You think about reliability and validity. If you have ever worked with Venn diagrams, you could think of validity, that accuracy dimension, in the following way visually. Let's say you want to measure aggression, your abstract construct. Well, there's some sense in which you have in your mind a really well-developed idea of exactly what aggression is. And then let's say you've got what you're actually measuring. Maybe that's the force of a hit that a participant hits the punching bag with in the lab, because that's the only kind of safe, ethical way you can do it in a laboratory. Your question when you're looking at validity, how accurately does it capture what you want to get at? You can think of it this way in terms of a Venn diagram. What you want is those two circles to have as much overlap as possible. And what you're asking is, how much does your measure actually measure what you want to measure? Let's go to the next slide here. So basically what you're going to have is something like this. You're going to have something that your measure captures that isn't actually aggression. Then you're going to have some portion of what aggression really is that unfortunately isn't captured by your measure. And then you're going to have some overlap, okay, where you've got what actual aggression is overlapping with what your measurement is capturing there. And your goal is to have those two circles overlap as much as possible. You want to minimize the part of aggression that is not being captured by your measure, and you want to minimize how much is being captured by your measure that isn't aggression, that is something else instead. Another way to think about validity, so that was in terms of Venn diagrams and reliability, is in terms of this bullseye illustration, which I think is simple, elegant, straightforward. How accurately did we get what we were going for? Well, did you hit the center of the bullseye? Did you hit where you wanted to hit? And you can think of validity in that way. A marksman who hits the center, that could be seen as representing a valid measure. Now, what if you had something like this? We had a cluster of dots close together here off the bullseye. Then that's going to have low validity because you didn't get what you were going for. Now, of course, reliability can also be viewed in terms of this bullseye visual, in that you could be consistent or inconsistent as well. If you hit the same spot reliably, all the dots would be clustered together, and that would be reliability. So this measure, for example, would be reliable because the marksman is consistent, and valid because the marksman is hitting the bullseye. Here, of course, all the dots clustered on the outside. This is going to be reliable, but not valid. Okay, so they're hitting the same spot every time, but they're not getting what they're going for. And then, of course, if you just had dots spread everywhere, then that would be an example of a measure that was neither reliable nor valid. As maybe has become apparent to you, you could have a measure that's reliable, but not valid. It's all those dots consistently clustered together in the perimeter instead of in the center. But it's difficult to have a valid, unreliable measure. And if you just think about this, you can understand why this is less common. If you are not hitting the same, if you're not able to hit the same spot every time, then it would be difficult to accurately be measuring what you're going for. If you can't hit the same spot every time, how could you be getting the bullseye, which is what you're shooting for? So much less common and much less difficult to visualize is having a measure that did accurately capture exactly what you were going for, but that was totally unreliable, that you're getting these inconsistent responses on. That's just a little less possible. But the point of this whole discussion about reliability and validity is to give you an idea of how measurements are criticized and the things you need to think about. And the take-home message here is it's really important for social scientists to consider what we're actually measuring and how well that's representing what we're going for, because we're dealing with these abstract mental constructs. It is really difficult to get perfect reliability or perfect validity. And so we need to not throw in the towel, because as long as, with that Venn diagram, we've got enough overlap, we can still learn something important about human nature. Alright, one more methods example. This is just to help you kind of engage in a thought experiment to make sure you've internalized pretty well all these ideas we've talked about in Chapter 1. Let's imagine a news story gets published, and you find out that people have done an analysis of various communities, and they've gone through and they've looked at all these data, and they've found that if you look at the days on which murders are committed, and you look up the corresponding temperature outside on those days, what we find is crime and murder rates go up. I just said temperature. When ice cream sales go up is what I meant to say. Basically, I revealed the potential answer here. Anyway, I have the flu, so be gracious. What I meant to say was, if people tracked ice cream sales and they found out that when ice cream sales are higher, murder rates are higher, everyone concluded eating ice cream increases murder. What I was going to have you do if we were in class was discuss that and think about what are alternative explanations for that relationship. And as you heard from what I just did there when I said temperature, what a lot of people interpret could be going on here is that ice cream sales go up on days when it's hot, and heat increases aggression. Okay, so that could be one reason why you would see that relationship if it wasn't actually the heat or the ice cream causing the murder rates to go up. That's that third variable possibility. So it's not that eating ice cream causes people to be more likely to murder. It's that there's this third variable in the background, the heat, that is both causing ice cream sales to go up and causing murder rates to go up. But remember, finding the correlation between ice cream sales and murder will still allow me to predict. You know, if I knew nothing about, people said, hey, I'm going to randomly sample a day from the calendar year, and you have to predict, will the murder rates be high or low? I could say, tell me how much ice cream was sold on that day. And if it was a lot, I might predict the murder rate was higher. And I would be right, maybe. Okay, so knowing that there's an association there allows you to anticipate and make predictions. But not being able to rule out the possibility that one is not causing the other, and that it's really this third variable in the background, the temperature, that is causing both to move together, is what's going to prevent you from staging the proper intervention. If you want to understand why, because you want to stage an intervention to reduce murder, you have to find out that it's actually the heat causing both to go up. Because we would not want to intervene and start banning ice cream stands from selling ice cream in the service of reducing murder rates, because that would not help if one was not directly causing the other, if it was just the heat in the background causing both to go up, because then what you'd be left with was a hot day, heat inspiring the same aggression, the same high murder rates, but it might actually even go higher, because everyone's even more frustrated now because they're all hot and they don't have ice cream on top of it. It would not make anything better. I do not advocate banning ice cream in any circumstance. So if you could quickly kind of think through that example, if I explained it in a more elegant, proper way initially, and I didn't give away the temperature explanation there, if you can quickly think through that and that'll make sense to you easily, then you're very comfortable. I think that means with this idea of correlation versus causality and what different designs allow you to conclude and not conclude. Okay, let's move on. These are just a few images that kind of express some of those ideas. Correlation does not imply causation. And let's quickly wrap up this chapter with a note on ethics in research. I've been alluding to this topic periodically throughout the lectures, but what are the biggies here when we talk about ethical concerns? When an ethics board reviews a research plan and says, do I think people should be able to proceed with this? What are the main things they're looking for? They want to see freedom from coercion. You can't force someone. You might realize that you don't have to go volunteer to do research in order to complete this class. Part of that is an ethics thing, that you have to have these alternative writing assignments where if you prefer to not lend yourself as a volunteer, that is totally within your right to do so. There is a equivalent experience that is supposed to take about the same amount of time and inconvenience, is the idea, that you can do instead, and that's related to this ethical concern of freedom from coercion. Informed consent, you got to be aware of any risks that are involved before you do it. You have to be aware you can change your mind if you're uncomfortable anytime and withdraw without penalty. That's part of it, just so you're not pressuring people if they get uncomfortable due to something you're doing to keep going because they think they're going to be penalized. And again, a big part of the informed consent is make sure that before they go into it, they know what the risks are. Another principle an ethics board is going to look at is they want to see limited deception. They want to see that the researchers have done everything they can out of respect for the participants to try to limit the degree to which they deceive them about anything. You are permitted by many ethics boards to deceive to a certain extent because it's often necessary to test your hypothesis. If you remember that example of the measure of aggression I talked to you about, where the person put hot sauce on the eggs they were preparing for their partner, there was deception there because the researcher told them that what the food they were preparing was actually going to go be served to this other partner who didn't like spicy food. In reality, it wasn't. And it wasn't because they didn't want to actually put somebody who had a low heat tolerance through the experience of eating that, okay? So they misled the participants. It was obviously necessary to do that if that was going to be a true measure of aggression. Because if you tell the participants this food is not going to be consumed by anybody, then it doesn't represent aggression in any way, how much hot sauce they dump on there. Important to the validity of the whole measure is that they think that they are administering harm to a person in the moment that they do it. If you can make a case for why you can't test your hypothesis in the same way without the deception, you just can't. An ethics board would say, okay, we'll allow that. But what they're going to do is kind of really skeptically put you through the ringer, the researcher through the ringer, where they're saying you really have to make a case for why you can't test the hypothesis without this deception. And you have to make a case for how you're not deceiving them about anything that would cause them harm. What a board is never going to approve is you putting in a consent form, if you agree to do this experiment, you'll experience no discomfort of any sort. And then you start shocking them. They're just never going to do that. So what you can't do is lie about anything that an ethics board concludes might reasonably have deterred them from choosing to participate if they'd known about it. So you got to make a case that your average undergrad, probably would have refused participation if they'd known that there was going to be this, this fib about the plate of food actually going to someone else. They had a good time. They got to make some eggs. When we debriefed them at the end, they thought it was kind of interesting and funny, And so, as long as you can make a case that people probably still would have agreed to participate, you weren't lying about the harms they were going to encounter or the discomfort they were going to encounter, then it is possible to use deception in research and get that approved. There's always got to be a full debriefing. Out of respect for participants that you misled, if you deceive them, they're also going to want to see that at the end you tell them about the deception. Apologize, explain why it was necessary, and give them a chance to ask any questions and withdraw their data from the set if they feel uncomfortable with having been deceived. Number 4, you want to see an adequate debriefing. I mentioned that has to include debriefing about the deception if you're deceiving, but even if you aren't deceiving, there's got to be a debriefing just in general, where you say if you have any questions, here's who you can contact. And confidentiality. Researchers have to keep everything they learn about participants confidential. You report aggregate data. You don't tie individual responses to names. If a research assistant sees you on campus, they're not supposed to say, hey, it's you. I just saw you from that study on blah, 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 Tuesday at 3. They're not even supposed to do that. Keep all of that stuff confidential. And those are kind of the biggies of things that an ethics board is looking for. And ultimately, it's all about Wade. How much does this have the potential to advance scientific knowledge versus the risks posed to the participants, and how is that balance? It's a subjective process. An ethics board at one university might approve something that one at another might reject. But you have to think about how you would weigh some of those things if you were on a board. Because all these things have to be considered in psychological research. And to close, quickly, there is some research conducted with animals that is very well known within the field of psychology, because that was a starting point that led to a lot of principles that were extended to humans. There's also a process for making sure that research is ethical when you're working with animals as well. Some of the principles here: you have to demonstrate that it can significantly advance our knowledge and it's necessary. The animals that are being used must be otherwise kept in good health. Oftentimes the interventions affect their health, but you can't just, in between experimental sessions, be keeping animals in a horrible, neglectful environment for no reason. And every effort must be made to minimize any unnecessary discomfort. But as you can imagine, this is an area where people really don't all agree on what is the proper amount of discomfort that an animal should be able to be permitted to experience in order to advance knowledge. So some people completely oppose using animals in any type of medical research. Again, there are, guiding principles there, but there's going to be ongoing debate and disagreement about some of those questions. All right, that's going to wrap up Chapter 1. Gonna direct you over to a chapter 2 file.